Okay, this topic is really for people who are going to go on to study, say, algebra, abstract algebra in college, let's say. There are a bunch of words here over on the left, closure, commutative, associative, identity, inverse, distributive, and so on. Let's just go through them very, very quickly. The property of closure means that if you've got two real numbers and you add those real numbers, you'll get a real number. So closure is something that applies to addition. It also applies to multiplication. If you multiply two real numbers, you'll get another real number. Now, commutative just means that if you change the order, instead of having a plus b, you do b plus a, you'll get the same answer. And that also works for multiplication. Notice that it doesn't work for division. If you do 10 divided by 2, that's different from 2 divided by 10. So division is non-commutative. Then we have associative property. It's exactly this thing here. If you add A and B, figure out an answer for that, and then add C, that's the same as adding B and C, and then adding A onto it. So associative, you can put brackets around the first two or around the second two, and it remains the same answer. And that same property applies to multiplication. The identity property, well, 0 is what we need for addition, because any number plus 0 gives you that number, that original number. A plus 0 is A. 1 is the identity for multiplication, because what you need to do to, if you're multiplying a number to get the same number, is multiply by 1. The inverse, the additive inverse of a number is negative whatever that number is. So the additive inverse of 5 would be negative 5. The multiplicative inverse of a number is 1 over the number. So, for example, the inverse of 5 would be 1 over 5, because 5 times 1 over 5 is 1. And then the last property here is the distributive property. It's really just saying that you can, if you want to calculate this, you can do A times B and then do A times C and add those two things together. AB plus AC, like that. For negatives, this first property here, this negative and then brackets A plus B is equal to negative A minus B. Well, you can see that in this example here. If you have negative in brackets 2 plus 3, that does give you negative 2 minus 3. It gives you negative 5. I'll just quickly go through the other properties too, just examples, and you could put in your own examples if you want. This next one, negative A minus B, is the same as B minus A. The negative before a bracket, you can think of the negative before a bracket as being like negative 1. And then so it's like having negative 1 times A, which gives us negative A, and negative 1 times negative B, which gives us positive B. So an example of that would be this here. Negative in brackets 5 minus 9 would be 9 minus 5. Negative 1 times anything is just negative, whatever that value is. Negative 1 times 7 is negative 7. Negative and then negative A gives you A. So if you've got negative 13, that's positive 13. If you've got a negative number times a positive number is equal to a positive number, the positive equivalent times the negative equivalent. An example of that would be right here. Negative 2 times 3 is the same as 2 times negative 3, and that's the same as negative 2 times 3, which should be negative 6. And the last thing, if If you've got two negatives multiplied together, that gives you the positive answer, 15. Then on page 4, we have some properties that help you to add, subtract, multiply, divide fractions. The key things are that if you want to add fractions together, you've got to have the same denominator. So it's nice and easy if you have 2 7s plus 3 7s. That gives you 2 plus 3 over 7. And then you can just do the 2 plus 3 to get 5 over 7. If subtracting is exactly the same. You do the 7 minus 3, that gives you the 4 over 9. Remember, the bottom stays the same, that denominator. And then if it's a little bit more difficult, if it turns out that the denominators are different, like they are in this example, you need a common denominator. Often the common denominator can be just the two numbers multiplied together, BD in this example. So, in this example, if we've got 3 7s plus 2 5ths, the common denominator is going to be 7 times 5. Now, if you're dealing with the 3 7s, the 7 has been multiplied by 5, so you've got to multiply the top, that 3, by 5 as well, which gives us the 3 times 5. And then this fraction here, the 5 has been multiplied by 7, so we've got to multiply the top by 7. That's why it's 2 times 7 on top. And then from there, we just calculate that out. 3 times 5 is 15, 2 times 7 is 14. Adding those up will give you 29 over 35. Now, multiplying fractions is much easier. It's as easy as just multiplying the tops, multiplying the bottoms. So if you've got 3 7s times 2 5ths, 3 times 2 is what you do on the top, 7 times 5 is what you do on the bottom. And if you do that, you should get 6 over 35. Dividing fractions, like in this example, this next example, if you do 1/5 divided by 3/4, what we've got to do is flip the second fraction. So instead of it being 3 over 4, it's going to be 4 over 3. And then we just multiply. And multiply the tops, multiply the bottoms, we get 4 over 15. If you happen to have, like in this example here, a common factor, the common factor is C. C is on the top, C is on the bottom. Then it's possible to divide the top and bottom by that common factor to be left with the values without that common factor. As long as that common factor isn't 0, then we have problems. Now, in this example here, we've got 24 over 33. Try and think of a factor of 24 that's also a factor of 33. If you do, you might think of 3. So 24 is 8 times 3. 33 is 11 times 3. You can then take out that 3, right? Remove the 3 from the top and the bottom. And if you do that, you'll get 8 over 11. And then this last example here, where we've got, whenever you've got something over something equals something over something, you can do what I call cross multiplication. You do the A times the A times the D equals the B times the C. So if you've got an example like the one on the right, x over 7 equals 4 over 5, what you can do with that is do the x times the 5, giving you 5x, and do the 4 times the 7, giving you 28. 5x equals 28. And then that's an easier equation to deal with. Now the last thing you have to do on page 4 is try to put these numbers here, these numbers 2.5, negative 3.7, and so on, mark them onto this number line, wherever they might be, and just write the number above it. So 2.5, for example, is going to be right in here, so you'll write 2.5, put an arrow saying where 2.5 would be on that number line. Okay, just try that, give yourself maybe 2 minutes to try that now, and then come back to this video to see the answers. Okay, well, I hope you've managed that. The numbers you can now check for yourself and make any corrections necessary are these ones.